problem number 12. Assume that we have an interval S, endpoints A and B, where A less than B. We're not saying, is this open, is it closed? We're not saying yet at the endpoints. However, we're saying there is a power series with the following property. S is exactly a set of points where the power series converges. The length of the interval is S, and the power series converges conditionally at x is equal to 7. What can we say about A and B? What's the radius of convergence? What's the center of the power series? These are all the questions we're supposed to investigate. And I'll say that some of these questions have multiple possible answers. We could say it either has to be this or it has to be this. So, big picture here about intervals of convergence. This is just going to be separate from, this particular problem right now. Is that, let's say that we have an interval of convergence with some positive but finite radius of convergence. So, here is the center in between. Here is the radius of convergence. Note the overall length is twice the radius of convergence. Or in other words, the radius of convergence is half of the length of the interval. So this already tells us, because we know the length of S is 8, we know the radius of convergence is equal to 8 divided by 2 is equal to 4. Okay, what else can I say just from this generic picture here? So inside, if you are strictly less than the radius of convergence away from the power series, away from the center of your power series, in here, you're going to absolutely converge. If you are outside, if your distance from the center is strictly greater than the radius of convergence, you're going to diverge. And at the endpoints itself, we don't know. It's possible that you'd have absolute convergence. It's possible you'd have conditional convergence. It's possible that you have divergence at the endpoints of the interval. Now let's read this carefully here. The series is it converges conditionally at x is equal to 7. The only place in this chart in which it can conditionally converge is either at the left endpoint or at the right endpoint. So this tells us that x is equal to 7. This must be an endpoint. We either must have a is equal to 7 or b is equal to 7. Either the right endpoint is 7 or the left endpoint is 7. So let's analyze these two possibilities separately for what's going on here. So suppose that a is equal to 7. So the left endpoint is 7 here. So in this case, we know our length is 8. So the right endpoint would be 8 plus 7 is 15. The center would be halfway in between. That would be 11. So in this case, we have a is equal to 7, b is equal to 15, and the center would be 11, and of course the radius of convergence would be equal to 4. And in our other case, b could be 7. So here is 7. We need to go back 8, which is to minus 1. Halfway in between minus 1 and 7 is 3. So, in this case, a is equal to minus 1, b is equal to 7. The center is equal to 3, and the radius is still equal to 4.